In this video, we're going to see audio clips and audio sources. So let's just import one audio here. So I'm just going to import a new asset. I'm going to take the audios from lab 4. And I'm going to take, for instance, the explosion of the player. So as you can see here, when we have in our project folder one audio asset, if you just click on it, you would find the inspector that is describing you this object. And this object is already an audio clip. So when you have an audio file in your project folder, that's automatically imported into Unity as an audio clip. Okay, and there are different parameters in here. So for instance, you have this one that says force to mono. That particular tick what means is that this audio clip is going to be forced to be mixed in a single channel. Okay, so that's the difference between a 2D channel and a 3D channel. If it's forced to mono, it means that all the sound is going to be thrown through a single channel, and you won't have the three-dimensional effects of sound. So if this the sound will be played the same, this particular audio clip will always be played the same independently of the location and the distance between the sound and the audio listener. Okay, there are other aspects here, like load in the background, that allows you to specify if this sound should be loaded in the main thread of the game or not. Ambisonic essentially allows you to identify if the sound field should be rotated based on the listener orientations or not. So in general, it's not going to be the case, but you can specify that. And then you have several default parameters that are very related to the actual audio file, which is essentially the compression format, the quality of this audio, and how to compress the audio, if you prefer to do compression during load, or compress it in memory, or just stream it from the audio file. Okay. Well, now what I'm going to do is I'm going to just go to the player. I'm going to add an audio here. So I'm going to just, you type audio source, you find that component here. And as you can see, you can specify here multiple parameters for the audio source, right? The first of them is the audio clip. And as you can imagine, this is where you can put your audio clip. So now that I have it here, I can just drag and drop it here, and you see that it shows up there. Okay. By the way, in the audio clip, you can also play it, so you can hear how it sounds. Okay. Now going back to the player, you have the audio clip here. You can specify the output. Normally, this is just going to go to the audio listener. If you don't touch it, it just will do that. But you can also have an audio mixer that is going to be doing specific operations on the audio. I will let that for you to investigate if you want to know more. For the moment, in general case, you won't need to touch this. There are several elements here that you can identify. So you have mute. Obviously this is pretty straightforward. If you enable it, you click on this one, then the sound will not do any sound. It will be muted. You have different bypass effects, so essentially effects that are accepting the reverb zone or the listener zone or the actual audio source, if they are going to be applied or not. So in general, if you click on these ones, those effects will be applied. Okay, play on awake. This is also quite self-explanatory. So as you remember, you have an awake function on the script. So if this tick is on, what that means is that this audio source is going to play automatically when this component, this object, is awake, when in the same step where the awake call could be called in a script. Okay. We have loop as well, that obviously you can imagine, that basically says that when the audio clip finishes, the audio source will play the video again. Okay. We have the priority. This is, as you can imagine, determines the priority of this audio. So if some audios needs to be dropped because there's too many sounds, this will determine which ones are dropped. The one with a lower priority will be dropped in case there are things that need to be swapped out. Okay. In this case, 0 is the most important one. So that's a high priority. That means that this won't ever be swapped out. And the low priority is 255 or 256, which tells you that if the engine decides to drop one audio, these ones are the ones that essentially will have less probability. It's not that important that this audio at some point is being missed. The volume is self-explanatory. Higher volume is higher volume in the final mix. So 1 is the highest, is no volume at all. The pitch, that tells you the speed of the audio clip. So 1 is set to normal speed. If you set it to more than 1, up to 3, you can make the audio clip to be reproduced faster. And -3 would be obviously being very slow. You have the stereo pan that essentially allows you to set the position of the stereo field in two-dimensional sounds. Spatial blend, again, that's between 2D and 3D, so allows you to set a complete balance. So in 3D, the position of the object, of this object that has the audio source, is important and is considered for the listener to reproduce the final effect of the sound. So for instance, if the object is very far away from the listener, then this distance will be taken into account in order to minimize the final volume of the audio source. Okay, and contrary to it just sounds the same everywhere. Okay, and then also, as I mentioned before, you can also have a reverb zone that allows you to essentially tells you which is the intensity of these reverb zones. How are they going to affect the final sound? There is another group of parameters here. It's called the 3D sound setting. So when the sound is configured to be 3D, you can modify these values. So you have, for instance, Doppler level. Unity simulates the Doppler effect. So when sounds are traveling away from or towards the listener, then the wavelength will be different, and therefore the way the sound is finally produced will also change, right? So you can intensify if you want no Doppler effect at all, or you want this to be maximized and be especially pronounced. Okay, the spread. This is essentially how does this sound spreads to the different to the speakers of the how is it spread around the different speakers. So you can set it between 0 and 200, and you can see here in this plot how the values of the different values, different parameters. One important one is the volume roll-off. Essentially, that tells you, and you can see that better in this graphics, is basically telling you with the distance how does the property of the sound, in this case the volume, is affected, right? So you have different types. You have logarithmic, you have linear, you have custom roll-off. So the logarithmic is this one over here. You can see the red line over here. So basically that tells you that at this distance the value is at its maximum, so at distance 0, and then it goes down very quickly to almost 0 when you are at 100, more or less 100 units of distance. Okay, so it's this is essentially a way in which you're gonna hear the sound when the listener is very close to the audio source, but as soon as you go a little bit away, it's just gonna fade off and you're not gonna hear it. Okay, this is logarithmic, obviously, because this is a logarithmic function. It just changed to linear. You can see how this line is a linear function, and then the distance is just gonna be linearly modifying the volume of the particular audio source. Okay, have another two sets here: the minimum and the maximum distance. So minimum is the is at which distance the sound will stay at the loudest possible sound. Okay, so essentially the distance outside this minimum distance will attenuate the volume as you go away from it. Okay, and the max distance is essentially the distance where the sound stops attenuating at. Okay, so beyond this point, the volume would be constant. Okay, so if you set a distance of, you can say, for instance, 50, clearly what this is doing is just saying it is going to be maximum at up to 50 distance. I think this axis is a bit off, because this 50 should be around here. And then it goes down linearly up to reaching 500. Actually, this line goes beyond 500, but if you set, let's say, 300, that essentially means that the attenuation is going to go down until 300, at this speed. Okay, it's a way to modify this the slope of this curve. If you set to 100, then essentially a very drop in here. Okay, it's a very linear drop at the value of 100. So it's essentially you can modify these values to tune how you want your sound to be attenuated by distance. And that's one of the most interesting things when you're working with 3D sounds.